Anna Fitzpatrick, banner ID 01809671. I have not collaborated with any other live human in the making of this video this evening. Good evening. Tonight we are going to be demonstrating by scatter plot the relationship between GPA and age given the data block that we were provided. And I am going to begin by explaining the response variable, which I have selected as the GPA, which will be on the y-axis. And we are choosing this as our response variable because each variable provides a different role. And I've chosen GPA as the response variable, because it's what we want to predict or explain, and it shows the result, outcome, and the variable of interest, i.e. predicting GPAs for different ages. For my predictor variable, I've chosen age, which will go on the x-axis, and that's because it's the explanatory or predictor. And for example, we're going to be trying to see how age will affect the GPA. So how we start by doing that is we go into Stat, Regression, Simple Linear. I'm choosing X as age, Y as overall GPA, and then I am computing. And we can see our first page is a summary of all the information, and the second page is showing our graph. And how I would describe this graph is it's a scatter plot. It has a large mass of information, especially clustered around the ages of 18 to about 28, it looks like, or into the 30s. There's no real form. I would say it's not really straight. It curves gently with a large cluster between those ages because that is the usual typical age that people would go to college. The direction does show a positive pattern. It does go from the lower left to the upper right. And what I can get from this information is that it does not appear that GPA decreases as people age, which is good news for all of us adult learners. The strength of it is, as I said before, the information is tightly clustered and there's really no discernible outliers. And I am now going to show you how I found the correlation coefficient. It is right here listed in our stats. It's 0.2495263, and I would say this indicates that the relationship between age and GPA are mildly correlated. 0.24 is not a strong correlation, but it is slightly positive. The correlation coefficient is the numerical measure of direction and strength of the linear association. There are three conditions that must be met. It must be quantitative data, it must be straight enough, and in this case it is straight enough. We'll look again at our graph. And there are no discernible outliers. And the correlation coefficient is between -1 and +1. And this does fulfill that criteria at 0.2495, and I've rounded that. Again, I'm going to talk about the independent variable, which is x, and which is age, because it's the predictor. It does not depend on any other variables. And the dependent variable, which is y, the GPA, is the response variable, because it does depend on another. So now, to sum things up, I am going to predict the GPA for a 25-year-old student at Housatonic. So again, I am going to go into Stat, Regression, Simple Linear. I'm checking age is my x, y is my overall GPA, and then if you scroll down, there is a way to predict y, which in our case is the GPA, and that is by putting in our x value, which is 25, because that's the age we're looking for, and then compute, and now it has included our estimated GPA for 25-year-old, which is 2.727, rounded up to 2.73. The other way, there is the calculation which you can use, which is predictor value is equal to the intercept b0 plus the slope b1 multiplied by the x value. And that is how you would do the calculation if you were using the numbers and not the software. The slope shows where the line hits the y-axis, and the intercept is showing how rapidly the y changes with response to the x value. So that is my explanation of these values tonight, and thank you. And I am happy to see that the stats are showing that the older students do well, but there really is a very mild correlation between age and GPA. Thank you very much. Good night.